Hello. Good morning, Mr. Badri, Mr. Tomoki, Mr. Tomoyuki. Do you can hear my voice?
Yes, we can hear you.
Yes.
Okay.
Yeah.
Okay, good morning. Mr. Tomoyuki, Mr. Tomoki, Mr. Badri from iCharm. And I'm also extend our warm welcome to our all distinguished representative from Director General of Water Resources in Ministries of Public Works. And we are please allow us to convey our apologies that our director, the Director of Water Resources Engineering Development, Mr. Birendra Jana, this morning is sudden unable to join, to be present today, to deliver his opening remarks, because there are some sudden matters to be handled this morning, and we hope we appreciate your kind understanding. So to make it brief, I will now proceed to the next agenda. Good morning, all of you. We from Directorate of Water Resources, Engineering Development, Directorate General of Water Resources, is our pleasure to welcome you to the technical meeting of the iCharm. With the iCharm, we sincerely appreciate your presence today's session. That this meeting is conducted to follow up to the previous discussion from the iCharm, which attending to our office before, and present their study about the assessment of flood risk quantitatively under climate and social changes, which is cases of the Solar River Basin. So today we are making following discussion about these matters, so that we can discuss more deep technical discussion, and we hope this result of discussion be as a basis of the collaboration between PU and iCharm through the MOU. Okay, and before that, some introduction from me that our agendas today will be the first is introduction from me from moderator, and then presentation from the iCharm about the last study, because there are some new attendance from this meeting, and then we are following to the discussion session, and we hope that discussion will be more technical and can give us more overview, so what in iCharm needs to us and what we can get the benefit from the study. Okay, so in this meeting we hope that we can discuss about the data source, methodology, and then assumptions and coefficient that the study use, and the technical recommendation, and to then obtain a more detailed understanding of the study analysis. So that can be established as a basis for a future discussion and potential collaboration between PU and ACAM through the MOU. So to make it brief, I invite the ACAM to present first about the study again, and after that we can discuss it more deep, yeah. Okay, to Mr. Badri and team, we invite you to give some presentation and welcome notes to us. The time is yours, sir.
Okay, good morning. Yeah, thank you very much
Good
for
morning.
having this meeting. So, we'll
Yes.
first briefly explain about our approaches and theories. Maybe first, our expert in GCM climate modeling downscaling and bias correction, Dr. Ushima, will briefly explain about our approaches, and then I will also briefly explain about our damage assessment. Yeah. Ushima, could you please start your presentation?
Okay, thank you. すえーっと、So, my name is Tomoki Ushiyama, senior researcher of ICHAM. So I'd like to introduce our climate model downscaling research in Soro River Basin in Indonesia. Thank you for your opportunity. Well, an outline of the climate change adaptation research in ICHAM is starting from the GCM data collection and downscaling into 5-kilometer mesh distribution to account for heavy rainfall causing flood using this kind of model. And this rainfall data is input to a hydrological model to assess the flood or drought condition estimation by our hydrological model, like a web RRI model, to compute inundation area, depth, and period or low flow. Then we estimate the flood damage, like agricultural damage or affected population, and drought damage estimate, possible irrigation area or harvest estimate. And finally, we implement e-learning utilizing the online synthesis systems to support policy planning for climate change adaptation or construct a prototype of climate change adaptation implementation or constructing OSS training facilitators. So this end-to-end approach, we have been implementing climate change risk assessment to various countries. In Soro River Basin, we start from the downscaling of GCM. Firstly, we based on the Japanese GCM, Meteorological Research Institute, atmospheric GCM. So this unique point is it has a high resolution GCM. It's a 20 kilometer or 60 kilometer resolution. And we downscaling this by using this WRF model into 5 kilometer grid interval and bias correction quantile mapping based on the ground rain gauges. This is our first results. So in the past climate, annual rainfall is like this. So in the mountainous region has a higher, larger rainfall, but in future climate, it will increase as the greenhouse gas emission increase, the rainfall amount is also increase. The lower panel is increase future minus past. And this is a monthly rainfall analysis and frequency analysis. So this is before bias correction. It's already a good agreement with the past climate data, and black line shows the rain gauge observation. So it's already good matching, but after bias correction, it's very good matching with rain gauge and past climate simulation. And in future climate, the rainfall will increase in the rainy season, January, February, March, and November, December. Another model also shows the increase in the rainy season and a little bit decrease in the dry season. And this frequency analysis, it shows the extreme rainfall will increase in future, like a 100-year return period or 200-year return period is the rainfall is increased this amount, or another model also increase in future. And we also implement statistical downscaling. This is more simple way of downscaling using the 8 different GCMs from CMIP5 dataset. This is past climate, and right is future climate. So from the 8 different GCMs, 4 of them shows increase similar to our dynamic downscaling, and 4 of them are not so much changed. But this result shows the uncertainty of the climate model estimation. Okay. And from our frequency analysis, we have obtained a 50-year return period or 100-year return period rainfall pattern. So using that rainfall data with simulating the hydrological model, we could obtain the inundation depths in the past climate and the future climate. So in future climate, the inundation area and water depths will increase in a longer year return period data. And this is a crop damage estimation model. So the paddy field rice plant has a different damage curve depending on their life stages. And using our inundation depths data and paddy field distribution map, we obtain the crop damage estimate like this. And this reported damage area and calculated damage area is more or less matching like this figure. So this agricultural damage in the past, present climate and the future climate with different return period. So we can estimate the agricultural damage will increase in future in the longer lead time. However, this estimate is based on the one GCM result, but nowadays the climate change risk assessment is based on the multiple GCMs or multiple RCMs. So we need to use multiple GCMs or large ensemble data of the climate experiment. So Japanese climate research group made this large ensemble climate data, the so-called D4PDF data. It's shown, the key point is shown by this D4PDF logo. So it shows average temperature histogram. So average temperature in the past climate is like this point with uncertainty, and this average temperature will increase in future with much larger uncertainty. So the histogram peak is a little less than the past climate. Anyway, they compute very long, large year climate data, like 6,000 year for historical data and non-warming scenario, and 4K increase future in 5,400 years. So they have non-warming scenario or historical data or 1.5 Kelvin increase or 2 Kelvin or 4 Kelvin increase. And computed by atmospheric GCMs, but based on the 6 different SST pattern obtained from the CMIP5 dataset. And they also downscaling into 20 kilometer resolution and 5 kilometer resolution in the Japan area. Using this downscaling data, so they compute the increasing ratio of extreme rainfall, and River Bureau of the Ministry of Land Infrastructure, Transport and Tourism updated their river management plan. So they start the plan from the historical maximum principle or statistical data analysis, but in 2022 they updated to consider the precipitation change factor by climate change. So as a result, in case of 2 Kelvin increase future, the rainfall amount is 1.1 times larger. It means a 10% increase in future in this yellow area of Japan. The Hokkaido area is a little bit higher ratio, but anyway, and 10% increase in rainfall will cause a 20% increase in river flow and 100% increase in the flood frequency in 2 Kelvin increase future. And 4 Kelvin increase future, the increasing ratio is much more higher. So using this result, they start updating the river countermeasure infrastructure starting from the major rivers in Japan. So we downscaling this D4PDF data set in a solar river basin. So this is a past climate annual rainfall, and right-hand side is 2 Kelvin increase future and 4 Kelvin increase future with different SST pattern. For example, this is CC pattern, the rainfall decreasing in 2K future, but MY pattern, the rainfall is increased. So there is a large uncertainty in the future rainfall distribution. This is RX1D, is a daily maximum rainfall in a year. So this pattern also show a little decrease in CC, but MY shows increase in future, but not so much a large uncertainty. And this is CDD is consecutive dry days. It means the drought a possibility in future. So, for example, HA shows very red distribution. It means the higher drought possibility in future. GF and MP also shows high possibility of drought condition in future. But MI shows this is a wet result, wet conditions, so not so much drought probability. And this is a summarized analysis of the monthly rainfall and frequency analysis. So left-hand side is our first results, and this blue color shows the 2K increase future by D4PDF downscaling. So the monthly rainfall has a large variability, but half of them increase in future and half of them decrease in future. And 4K increase future also large variety. And the right-hand side is all average of different SST patterns. The interesting point is the extreme rainfall in 2K increase future also increase in future, but increasing amount is less than our first results, and 4K increase future is a little bit smaller increasing magnitude compared to 2K increase. So this data is used for hydrological simulation. The first figure is monthly rainfall, and second row is a discharge at a set point in the middle stream. The daily discharge in annual average is a little decrease in 2K increase scenario, but increase in 4K increase scenario. And the monthly discharge pattern, 2K scenario shows mostly decrease in the monthly discharge. But the 4K increase scenario will increase in January to April, but other months are decreasing. And this is also a discharge at the set point. Left-hand side is a high water condition. So in case of 2K increase scenario, more than 2,500 cubic meter per second discharge, it will increase in the future in 2K. And 4K increase scenario is mostly increase in future compared to past discharge. But in a low water scenario, less than this point, like 100 cubic meter per second, the 2K increase future is decrease in a discharge at this point. And in 4K increase future, below this point is a decrease in future discharge at this point. So this is at the result at this point. And using this discharge changing data, we will have a damage estimate study in the next step. That's all for my presentation. Thank you very much for your attention.
Okay, thank you very much, Ushiyama-san, Dr. Ushiyama. Dr. Ushiyama briefly introduced our approaches and methodology of GCM products downscaling and also bias correction. So using the MRI GCM products and also G4PDF products, and also so how changes in precipitation pattern and also other climate variables,
Itu biar
including
bisa ada kayak kemarin lagi tuh gimana sih tulisan-tulisan itu? Tulisan-tulisan mana?
so
Yang dia
changes
ngomong
in
itu.
and others. So now maybe I will briefly explain about our damage assessment methodology. Okay. Ushiyama-san, could you please close screen sharing?
Sorry, again, please.
Screen sharing. Could you please close your screen sharing?
3 page.
Screen sharing. Exit. I mean, could you please exit screen sharing?
I couldn't catch your points.
共有を止めてください。
はい、わかりました。これ、違う。How can I stop?
Okay, yeah, thank you very much. Can you see my screen? Hello? Yeah, okay. Yes. No, not for sure. No present.
Mm. The same.
What? No.
Yes.
Yeah. Can you see my PowerPoint slide?
Yes, okay, sir.
Yeah, okay. Now, okay. Now,
Disappeared.
okay. Now, okay. Now, okay.
No.
No? Please wait. No.
Okay.
Yeah. So maybe I will explain like this. Okay. Sorry for some small interruption. So this presentation was also we introduced in our last meeting in the February, and I think in, some new participants also attending in today's meeting. Dr. Ushima briefly explained about the GCM product downscaling and bias correction. So by using those downscale and bias corrected GCM products, so we input into the hydrological and hydrology model and then simulate the flood characteristic, including flood depth and then we assess the damages. So my presentation is more focused on how we quantify the damages using a climate product and also considering changes in social, for example, land use and cover changes in the future and also changes in the population. So one of our current environmental and social concern is the impact of climate and social changes, how those drivers will impact to our society, and also how we prepare to cope with such impacts. So to answer those questions, so we need to better understand impact of those drivers on society and plan and implement proper mitigation and adaptation measures. And this slide shows the overview of the flood risk assessment method, so which consists three components. First one is the hazard components, and second one is exposure component, and the third one is the vulnerability component. So for hazard assessment, so we employed hydraulic model called water and energy budget based rainfall runoff inundation model. So in this model, so we can simulate water exchange between the atmosphere and also the land surface, and also we can simulate rainfall runoff processes and also the flooding simultaneously. And for simulation under climate change scenario, we can also input GCM products, for example, precipitation and also other climate variables into the model to simulate the flood condition under different climate change scenario. And second component to assess the exposure. So we use the globally available population data and also land cover data collected from the Ministry of Forestry and Environment. By using those data, so we can identify exposed elements in the hazard area. And third component is vulnerability assessment. So by applying damage curve, which shows the correlation between hazards and the damages, so we can quantify the damages. So in my presentation, I will focus flood damage to rice crops and also the residential houses and the contents. So this figure shows the developed damage cost for the rice crop. This one is for developed flood damage cost for the rice crops. And right side shows the developed damage cost for the buildings and also for the household contents. So flood damage to rice crops was defined as the function of flooding duration and also the growth stage of the rice plant, and the flood damage to houses and the building contents was defined as a function of the flooding. And to better understand how land use and cover changes and incorporate changes in a battlefield area in the rice crop damage assessments under climate change scenarios, we analyze how land use and cover changes in the historical years, and this based on the learning uh, in the land use and cover changes trends for the historical period. So by using machine learning techniques like modules for land use land change evaluation, which is QGIS plugin, so we can also project the future changes trends. And in this figure, this upper figure shows the historical land cover maps, and this bottom figure shows the projected map for the future. And to assess the house damages and also to exposure assessment, for example, to estimate the affected population and also to estimate number of inundated houses in the future, considering future population. So we use SSV-based projected population. And developed method was validated and calibrated for historical flood event. So, for example, we calibrated wave RRI model parameters by comparing calculated discharge. Also, we compare calculated flood extent area with the observation for the historical flood event. Then, after we calibrate and validate both hydrological model and also the damage assessment method, so we apply this validated methodology to assess the damages under climate and social changes. And these are the results of comparison of calculated discharge with observation at Cebu station. And this bottom figure shows the calculated flood extent areas with the satellite-based observation, and also we check with the reported flood affected districts. And this slide shows the calculated rice crop damages for the 2007 flood event. This left one, and this table bottom this table in the left side compares the calculated rice crop damages, also the affected rice crop areas with the reported data as a validation of developed rice crops damage methodology, and right figure shows the calculated household and content damages for the 2007 flood event, and also table shows the comparison of calculated results with the reported data. So in this study, so we also analyze how changes in paddy field area, for example, reduction in paddy field area in the future will impact in the rice production in the future. Here we can see due to reduction in rice field area in the future, so more than 3,000 billion Indonesian rupees will be lost in the future. And this figures shows the calculated flood inundation area and also peak inundation volume for the historical and the future climate period. So in this case, we these are the results in case of using EMR HCM 3.2 yes products. And here we can see not only flood depth will be greater in the future flood event, but also flood duration will be longer in the future due to climate change. And also large area will be inundated frequently with greater flood depth and the longer flood duration in the future flood events. And this figure shows the calculated damage per area and also the estimated damage value for the historical and also the future climate periods For the future climate periods, we have used three PADD scenarios. For example, 2020 PADD area, and also the projected PADD area for the 2014 and 2076. And then this one compares the calculated average density value for the past and the future climate period. And this figure shows the estimated exposed population and also inundated houses for the past and the future climate periods. For the future climate periods, we have a different scenario of the population, including base year population for 2000, and also we have used different socio-economic, different SSP based scenario. And this figure shows the exposed population in the high flood depth area. For example, more than 40,000 people will be exposed to the higher flood depth or more than 2 meter flood depth in the future. These figures show the calculated results of building and content damages for the historical and the climate period and the future climate periods. And this also the spatial distribution of the calculated average damage value for the past and climate period. And this slide shows the one of the example of application of damage assessment method. So, for example, damage assessment methods can be applied to evaluate effectiveness of any proposed or existing countermeasures. And this one is one example of if Onigiri Dam is used for flood controls based on its current capacity. Here you can see more than 20% damages to building contents and livestock can be reduced. So these are overall of my presentation. Yeah, thank you very much. So now I think we can move on to the question or comments if any.
Okay. Thank you, Mr. Badri and team. We already get your presentation, and now we will move to the discussion session. Yeah. Maybe is there any question for the participant who will ask to Mr. Badri and team? Silakan kalau yang ingin bertanya dari dua presentasi yang disampaikan oleh tim iCharm, kami persilahkan Bapak Ibu sekalian. Okay, maybe from because this case is Bengawan Solo, yeah. Maybe now we here there is a participant from Bengawan Solo. Maybe from Bengawan Solo, is there any question about the presentation or additional information to us? Kami persilahkan dari Bengawan Solo. Okay, maybe from another participant, BHLK, Balai Hidrologi. Jika ada yang ingin ditanyakan terkait paparan. Okay, maybe another participant. Mr. Badri, can you share the presentation to the chat so that the participant can have the file. Yeah. Is it possible?
Hello? Related to climate modeling or damage assessment?
Both. If possible, both.
Yeah.
You can share in the chat column.
Chat? Okay.
Yeah.
Ushiyama-san, could you please share? Is it possible to share your presentation in chat box?
While we are waiting for the file, maybe who will ask? We are. Please, silakan.
Okay, thank you, Bunila. I want to ask a few questions for HM team. First of all, thank you for your insightful presentation. I have a four question for today's presentation. First, considering the comparison between dynamic and statistical scaling that you use, could you please elaborate how difference between approaches are addressed to a consistent interpretation of the result? And the second one is, given that CMI5 models show varying trends like a weather condition and other drier conditions, how does this study account for this uncertainty of the analysis and decision making? And for the third question, could you also clarify the selecting of MRI ADCM as the model for dynamic downscaling? And the last question, also, can we know about more details on data sources on this study, including the type of data and temporal coverage rate time series applied in the analysis? Thank you.
Could you please repeat or maybe type in chat?
Okay, I have four questions. For
Yeah.
the first one is considering the comparison between dynamic and statistical downscaling at the first presentation.
Yeah.
Could you please elaborate how the difference between this approach are addressed to ensure consistent interpretation of the result? Is the first question.
Yes.
Maybe go one by one.
Is it okay to go by
Okay.
one by one? Yeah. Yeah. Ushiyama-san. Ushiyama-san. You're muted. Ushiyama-san.
Sorry.
Yeah. So first question is about processes between dynamical and statistical approaches.
So basically, statistical downscaling is kind of a bias correction method. So based on rain gauge data, so we can convert the GCM data onto the rain gauge observation data points. So it's very simple, and using that method, we can estimate the future change of the rainfall or temperature and so on. But dynamic downscaling is using the meteorological model, so we can have very consistent data like wind speed, temperature, humidity, and rainfall. So with depend on the complex topography. So dynamic downscaling is more suitable for heavy rainfall change in future, but it needs high computational costs, and so it has merit and demerit between the two methods. Is it okay for the explanation?
Okay, understood. Thank you. And we next to the second question. Given that the CMIP5 models show varying trends, that's indicating weather condition, and the other is drier condition. So how does this study account for this uncertainty of the analysis and for the decision making?
I'm sorry, I couldn't catch your point very well, but
Um,
say,
uh, based on your presentation, you already said that some indicating weather condition and some in drier condition, right? If
yes.
I'm not mistaken. And how does the analysis is um, can be used this uncertainty can be used and subscribe and okay, as a basic for decision making. It
Like,
was uncertain, right?
yes, yeah, there are a large uncertainty in the future climate. So, yeah, actually, we we don't have a com complete idea of how we can use that uncertainty. So, so there is a possibility to much high increase or low increase or so drought condition can be large or small. So, so we understand there are a lot of uncertainty in the future climate condition. So we need to prepare for the to uh, considering that large uncertainty. Yeah, that is our understanding so far. Is it okay? You are speaking, but muted.
Hello, we cannot hear you.
Miss Fadila, we couldn't hear you.
Okay, I'm sorry.
Okay.
Okay, I get it. And
Mm.
we can move to the third question.
Mm.
Could you clarify the rationale for selecting MRI AGCM as the primary model for the dynamic downscaling? Why don't you use other models? There is any justification?
Just justification of the model. Uh, mm, it's
Maybe Mr. Tomoki, she mean that why do you choose the MRI AGCM? Why not use the other model? Yeah. What's your justification? Maybe you can explain to us.
Yeah, it's the point is this MRI GCM has a very high resolution GCM, and that's why it has a capability to produce a good rainfall distribution estimate, and the model developer validated by a comparison of rain gauge and model results and show it's a very good capacity. That is why we use that model. Am I answer your question? You are muted.
I think it's not really clear for me, Mr. Tomoki, because can you clarify to us, is that any comparison between MRI ADCM with other models? Well, you should do that rather than other models. Is that any comparison, like scientific, like original, is which one is more detailed or maybe more valid to use in Indonesia?
Yeah, right. I got to your point. But yeah, but actually, the reason why we use this model in the Japan area, so we have good reason because Japan has a bayou season, that the bayou front is made a lot of rainfall in June, July season, and to produce that rainfalls, we need a high resolution GCM. That's why the Japanese group use the high resolution MRI AGCM model. But as you say, we better check the other GCMs. Yeah, that's also a reasonable idea. But so far we have this large ensemble data made by MRI AGCM, so we utilize this data set. Okay.
Okay, Mr. Tomoki, I got your point. And for the last question for me, this is the last. Can you please provide more detail that the source you used in this study, including the type of data, coverage period, and the time series of the data? Thank you.
Data. The first results of the MRI AGCM data, the one set is 25 years for like a past climate or future climate with different scenario. And D4PDF downscaling, one set is 30 years. But for example, in past climate, we have 6 ensemble, so total 180 years for past climate and also 180 years for future scenario for each of 2K increase and 4K increase. And all 5 kilometer grid interval model. It's okay?
Okay, Mr. Tomoki. Thank you for your explanation. I just remind that I have other question if you want to answer it. I see at Mr. Sresta presentation, there's use of some models like SSP and RCP H.5. Can you explain to me what's the rules, linkage, or any justification why you use some model at a study?
Do you mean SSP1 to SSP5 shared socioeconomic
Uh,
pathway population?
I'm sorry, Mr. Sresta.
Yes, yes.
On your presentation, there is SSP models and also RCP models.
Yes.
Is that
So
used?
about that model, Dr. Vishiyama already explained about we use MRI AGCM RCP climate model output. Climate model output. MRI AGCM product.
But the RCP scenario is come from the CMIP5 scenario,
Yeah.
and
Yeah.
SSP is CMIP6.
Yes. But what we mean that in your study, do you use RCP or SSP?
So in this case, we use CMIP6 product RCP scenario for the future, and SSP
Yeah.
scenario is only used for the population projection.
Oh. Sorry, can you repeat? We don't get it.
In my presentation, so I presented results using MRI, AGCM, RCP scenario, not the SSP scenario, CMIP5.
So you use the RCP, not SSP, yeah?
Yes, for the climate change. Yes.
Yeah.
Yes.
And why don't you use SSP? Because SCP is already, I mean, the previous CMIP5, yeah. Now it's
Yes.
CMIP6, yeah, if I'm not mistaken, yeah. Why don't you use the new one?
So in our next future plan, so Dr. Luciana already presented the use of D2PDF products using different symbols. So maybe in our next plan, so we will use D2PDF outputs.
Okay.
Yeah,
Thank you.
actually, this work was started before CV6 available. So I presented
Yeah.
this
Okay.
last year.
Okay, thank you.
Yeah, Ushiyama-san, do you have any comments?
No. Yeah. No. So maybe we need to update to SSP scenario in future.
Yes, because now maybe commonly using SSP, yeah. They are getting to use SSP, you know. But we in Indonesia also some using RCP, yeah. But now we are migrating to SSP. Yeah. Yes. Okay. Is there any other who wants to ask or give comments? Silakan kepada para peserta rapat kalau ada yang mau ditanyakan. And maybe Mr. Badi, for the source of data, do you
Yes.
get from the BBWS Solo or you just get from another source? Yeah, because it's specific to Solo, yeah.
Yeah, so we obtain rainfall and this data from Bengawan Solo, BBWS, and also some data obtained from Kusaya.
Okay.
Yeah.
Okay. Based on your study, after you got the result of the study, do you have any recommendation, yeah, for for Solo, yeah, especially, yeah, for action plan or continue study for the study or action plan that we should take, yeah, after your result study, yeah, because it's not stopped, yeah. So next what? Okay.
So maybe next step, so maybe we need to think about how to reduce. So based on our results, so flood impacts or damages will be more severe in the future. So we need to develop strategy by linking sign-based outputs to implement some kind of effective preventive or some measures to formulate some kind of policies to regulate land use land use planning. Is it okay? Hello?
Okay. Yes. Okay. So compared to the Japan, yeah, maybe you have also the same study like this for Japan. How about the result? I mean, the differences, yeah. Yeah, I'm asking about this study. Maybe you is it are you conducted this study also for Japan? I mean, I want to know the result, yeah, the comparison, yeah. If there is any study which is same like this, and if there is the next step for Japan, what do you suggest, if any
For
study
example,
like
I think
this?
there are some other colleagues are doing damage assessment, also using extreme event and also GCM. But we assess damages under climate change for different river basin in the Asian developing countries. And in our future studies, we use more GCM products and also consider social changes to assess damages and impact and to better prepare for the future.
For the Japan itself, are the Japan already prepare some action to adapt the effect of climate change or not? Do you have any study for that? Maybe you can share to us.
Okay.
But if not, it's okay.
Ushiyama-san explained the flood control plan in Japan's case. That's one application. We use the results of climate change impact for Japan the different regions in Japan and increased the target flood level in the future. So that's one application example we just shared. And regarding the other cases, we may look for some study results, but they are not available immediately. Not in our hands now.
Okay.
Is it okay?
Okay, thank you, Misal. Maybe this is Mr. Miftah ya. Please silakan Pak, if there is any question.
Okay, thank you, Miss Nila, for giving me a chance. So I have a general question, man. Sorry, before I'm so sorry. I just joined in the middle of meeting. So my question for Mr. The Mr. Badri
Yes.
Sereta.
Yes.
So from my perspective, this study appears to focus more than the application of existing models and frameworks, particularly the web RRI model and risk-based approach. So you can kindly clarify whether there are any aspect of methodological development involved or if it's purely an application. Thank you.
So you mean use of WebRRI model? Hello.
Yeah,
So
hello. It is there any aspect of methodological development in your study, or if it's only a pure an application? So it's only
okay. So understand. So in this case, we develop a methodology to assess flood damage to rice crops and also to houses quantitatively. So we develop or damage crops that can be applied to the flood prone area in the Solar River Basin, and also we validated those methods by comparing calculated results with the reported data. So in
okay.
integrate statistical hierarchy model and also damage estimation model to quantify the damages and losses. Okay.
Okay. Thank you for your explanation, Mr. Bardi.
Okay. Yeah. Thank you very much.
Ini sih udah yang Oke, ada lagi Bapak Ibu sekalian yang ingin ditanyakan? Maybe Mr. Badri ya, I want to
Yeah.
ask for the population ya, population data
Yeah.
ya. Do you get the data from the global population data sets ya, not from the local Indonesia like BPS data ya?
Yeah. So in this case, so for historical flood event, we use WorldPop globally available data, and for the projected population also we use global the available SSP based different scenarios of population projection.
Why
So because
why don't you use the local data from Indonesia? We have BPS ya. Apa sih
yes,
bahasa Inggrisnya?
we also compare those data with the local data for the um, whole basin. But our study is distributed grid-based analysis, and so we use the gridded globally available population data to assess. So maybe in the future, so we can also by incorporating local data, so we can also make some correction in those global data sets.
Okay, but now you're still using the global data ya, global
Yes, yes.
population ya data.
Yeah.
Oke, baik. Mungkin ada lagi dari Bapak Ibu sekalian, silakan. Okay, Mr. Barry. Maybe do you have any comment or ask or question to us if there is any?
So today, Dr. Ushiaman, Badri explained climate change analysis and application to agricultural damage assessment. From Indonesian side, from Peru, would you like to hear the more details process or data sources, any other applications related to today's presentations, or at this moment, are these today's presentation sufficient to you to understand overall climate change assessment method we are using? So that's my question to you.
Okay, thank you, Mr. As a general, we already informed about more detail about your study, yeah. But some of them maybe the source of data is still using global data, yeah, not local data or focusing on the data Solo, yeah, especially in Solo, yeah. But as a general, we already get the point, yeah, for your presentation. But if you're not, if it's okay, if you can not maybe not in this discussion, yeah. Actually, we already write down some detailed question to you. Maybe you can respond is by maybe you can
Okay, yes.
respond it in written, yeah. not maybe, so and maybe you have to prepare, yeah, some more detail, yeah. If you're okay, but as a general, we already get the point, and but maybe if you are okay, you can respond our question in the written model in the written, yeah. Okay.
Okay. Okay.
The letter.
Yeah. Yes. So we will check your question presentations we just received before this meeting, and we will provide necessary answers to your questions.
Yeah.
Okay.
Yeah, we hope that this study, like the use of data and also the methodology that you're using, yeah, or the application, can be maybe we can use it in the another place, another location, yeah. But the first thing that we have to make sure that type of data do you use and something like that, yeah. Yeah.
Okay.
But
Thank
so
you.
okay. Okay, thank you.
Yeah. So, Ushiyama-san, Shireshita-san, do you have any requests for Peru?
Yeah, so currently, we use, as you mentioned, we use global data. So if we can obtain local data like the population, so we can replace those data easily. And also, we validated our model for 2007 flood event, and if possible, to obtain recent rainfall and discharge data for recent flood event. Also, we can save our wait list for recent flood events.
Okay, Mr. The one thing is actually we need the workflow or flowchart of your calculation, yeah. What's the starting,
Yeah.
what kind of data, and then what the methodology, and then the output data, and the output data is using for what another data. I mean, the first things we need that, yeah, so that we know what kind of data do you need. And then the second one, to further collaboration of the data, I think we need to formalize the MOU, yeah, if okay with you. So maybe in the next step, we will we'll finalize the MOU, and we will send to you, so that after that we can hopefully conduct the collaboration of the study and the data. So there's two things that should be conducted. First, the work of the flowchart of the calculation and what kind of data that do you need actually for local. And then the second one, we will update the MOU, yeah. We'll process the MOU. And we need another discussion about the MOU. Maybe that's, yeah. And then we can go through to the another step after those things we finish conduct. I think that's.
Yes, we are okay for your suggestion about the next step. And any comment from Ushiyama-san?
I have no comments so far. Thank you.
So we are okay from our side.
Okay, thank you, Mr. From dari teman-teman SDA, dari para peserta, apakah ada yang mau ditanyakan atau disampaikan kembali? Baik. Okay, Mr. Badri and team, since there are no more questions and question to you, and from our side is enough. It's also enough. I think our discussion today is enough, yeah, Mister, and we can finalize it and we can end it today. So in the next step, we will waiting for your response about the question and about the data that you need, and we will also update for the MOU. Yeah, maybe there is another team from us which will be process it, then and it need more discussion with that. And then we from in PU will say thank you for your time. Yeah, for your information, and I hope this discussion can continue to another level. Okay,
Yeah,
I
thank you so
think
much.
that's all for today. Thank you.
Before,
Good
just before
day.
closing,
Yeah.
could you let us take the group photo, showing
Okay.
your participants turn on the camera. If
Mungkin
you are
bisa
available.
dibuka kameranya ya untuk dokumentasi.
Okay. So are we ready?
Okay, yes, sir.
1, 2, 3. We have several pages, so please wait. So 1, 2, 3. I'll take next page. 1, 2, 3. Next page. 1, 2, 3. So please, I will check. Wait a moment. Yeah, okay. Yeah, thank you very much.
Okay,
So much.
thank you very much, Mr. Badri.